So in this video, we're going to talk about how to find values of trig functions for angles and use trig functions to find side lengths and angle measures. So you learned about the first three trig functions, which are sine, cosine, and tangent back in geometry. So now we're going to learn about the reciprocal functions. So what you do is you basically take these original trig functions and you just flip them upside down, right? You find the reciprocal. So sine theta is opposite over hypotenuse, and the reciprocal is cosecant theta, hypotenuse over opposite. Cosine theta has a reciprocal secant theta, and tangent theta has a reciprocal, which is cotangent theta. So let's try this example. It wants us to find the values of the 6 trig functions for the angle theta in the triangle below. So whenever you're doing these triangle problems, remember to find all 6 trig functions, you need all of the sides. So since these are all right triangles, you want to go ahead and use the Pythagorean theorem to find any missing sides. So my first step is just going to be to do that. So I have a squared plus b squared equals c squared, right? The Pythagorean theorem. So I have a squared plus 12 squared equals 13 squared. Okay, so I have a squared plus 144 equals 169. And then if you do the algebra to solve, you get a squared equals 25. So you have a equals 5. Okay, so we have this missing side. So let's now go ahead and find all of the missing trig functions. So I'm just going to list them all out. I have sine theta, cosine theta, tangent theta. And then I have the reciprocal functions, which are cosecant theta, secant theta, and cotangent theta. Okay, so sine theta is going to be opposite over hypotenuse, right? So I have 12 over 13. Cosine is going to be adjacent, so remember the adjacent side is 5, so I have 5 over the hypotenuse, which is 13. Tangent is opposite over adjacent, so I have 12 over 5. And then once you find these 3 functions, if you write them in this order, you just have to now find the reciprocal. So you just flip all of these. So sine is 12 over 13, so cosecant is 13 over 12. Cosine is 5 over 13, so secant is 13 over 5. Tangent is 12 over 5, so cotangent is 5 over 12. And that's how you find all 6 trig functions. So now you can go ahead and pause the video and try doing this example on your own. So in this one, once again, I went ahead and did the Pythagorean theorem to fill in all the missing sides. So here it's a little bit different because our hypotenuse is actually a radical, so it's a square root of 34. Remember, whenever you have a radical in the denominator, you want to rationalize by multiplying the numerator and denominator by that radical. So when you do that, you're going to get 3 square root of 34 over 34. And then when you do the reciprocals, you actually don't have to do it on the rationalized version, because if you do that, your radical is going to be in the denominator again. So you want to go back to the version you originally wrote, the opposite over hypotenuse, and then just flip that one when you get the reciprocal. Okay, so you can see here I have all 6 trig functions listed out for this angle theta. So now let's try this example. So it tells us that the tangent of A is 7 over 3, and we want to find the exact values for the other 5 trig functions. So let's think about what tangent means. Tangent of A means opposite over adjacent, right? So the tangent of A is going to be 7, and then the adjacent is going to be 3. So now let's find the hypotenuse, right? So this right triangle is kind of upside down, but remember that these values we have are actually the legs. So we have a squared plus b squared equals c squared. So a squared is 3, 3 squared plus 7 squared equals c squared. So we have 9 plus 49 equals c squared. So we have 58 equals c squared. So that means the square root of 58 equals c. So now let's go ahead and find the other 5 trig functions. I'm going to go ahead and write in this side. So we have sine of a, so that's the opposite. So that's 7 over the hypotenuse, right? Square root of 58. Remember, once again, we have to rationalize because we don't want any radicals in the denominator. So we have 7 square root of 58 over 58. Now the cosine of a is the adjacent over the hypotenuse. So we have 3 over the square root of 58. So we multiply by the square root of 58 over the square root of 58 because we want to rationalize that denominator. So we have 3 square root of 58 over 58. Okay, so we can't simplify that any further, so we're just going to leave it. Tangent of A, that was already given to us, right? So we just have 7 over 3. So now what I'm going to do is I'm going to take all of these 3 functions and then I'm going to find the reciprocals now. Okay, so I always list them in the same order, and I just remember it goes with the opposite letter. So sine, the reciprocal is cosecant, right? So if it starts with S, the reciprocal starts with C. So cosecant theta, see, cosine starts with C, so the reciprocal starts with S. Sorry, these should say A, not theta. And then cotangent, well, that's the only one. There's no pattern in the letters, but okay, let's go ahead and find the reciprocal. So we have square root of 58 over 7. See, once again, I'm going to go back to the original, not the rationalized form. Secant is going to be square root of 58 over 3. And then cotangent, we just flip the 7 over 3 and we get 3 over 7. Okay, so we have these three functions. And then remember, we want to use the rationalized versions for these three. Okay, so now you can go ahead and pause the video and try doing this example on your own. So this one's interesting because we don't actually have to use the Pythagorean theorem. It gives us cosine A, right? So that's adjacent over hypotenuse. So you kind of have to sketch your own triangle. So cosine A, we have adjacent, which is 35, and hypotenuse, which is 37. And then the secant is, remember, the inverse of the cosine, but it gives us the secant of the other angle. Okay, so notice that this is for A and this is for B. So cosine is adjacent over hypotenuse, so the reciprocal is hypotenuse over adjacent. So that means that this 37 over 12, well, we know that 37 is the hypotenuse from the cosine of A, and then 12 is the adjacent side to B. Okay, so be careful there, adjacent side to B, not adjacent side to A. So now that we have all these three sides, we can find the value of cotangent A, right? Cotangent is the reciprocal of tangent, so instead of opposite over adjacent, we're doing adjacent over opposite. So if we go to A and we do adjacent, that's 35, and then the opposite is 12. Okay, so 35 over 12 is the cotangent of A. So now here, this last problem wants us to find the value of cosecant 42 degrees to the nearest thousandth. So you can actually use your calculator to do this. Remember, you always want to check that your calculator is in degree mode, right? Because this is giving us an angle measure in degrees. So cosecant, remember, is 1 over sine. Okay, so the reciprocal functions we cannot actually do in our calculator. What we can only do are sine, cosine, and tangent, right? Just like you learned back in geometry. So what we're going to do now is find the sine of 42, okay? And just go ahead and use your calculator for that. So the sine of 42 is 0.66913, okay? And now we need to find the reciprocal of that. Okay, so you just do 1 over, and then just go ahead and type in that number, 1 divided by 0.66913. And then when you go ahead and find that, so it says nearest thousandths, so 1.494. Okay, so that's how you find that. So remember, in your calculator, you can only find sine, cosine, or tangent. And then if you need a reciprocal, you just do 1 over whatever number it is that you find.